Hello everyone. Let us start with our new chapter, that is last one, vector differential calculus. In this chapter we are going to see the vector derivative of vectors, that is vector differentiation, and some theorems based on vector integral calculus. Okay, let us start with the definition of a vector. In general, vector we have one definition for vectors. We know vectors can be defined as we have two terms, vectors and scalars. Scalar can be defined as the terms or that entities which have which have only magnitude. That means mass. For example, mass, distance. These are examples of scalars. Distance means distance and mass. They don't need any direction. They have only magnitude, right? That's why they are called scalar. They need only magnitude. There is no any need to define such term. There is no any need of direction to define such entities. That's why they are called scalars. For example, constants, numbers, they are also scalar. 1 2 3 4 abcd. We are using those in examples. Those are scalars. And opposite of that we have vectors. Opposite means the vectors, in addition to the scalar, they need two things, one magnitude and both direction also. For example, gravity or weight, okay, velocity, acceleration, okay, these things, speed, okay, these things needs both magnitude. Means, for example, suppose speed, a particular vehicle is moving in a particular direction and with a particular speed with kilometer per hour and so on. That means these things needs both magnitude as well as direction also to study those things. That's why those are called vectors. And for scalar only we need magnitude. Now we are going to see how vectors can be defined or vectors can be written in the mathematical form and their differentiation. Okay, let us start with the basic thing, that is a position vector. Let a particle p, suppose a particle p is moving in a space. Space means which have three dimension space, x axis, y axis and also z axis. Okay, with the position vector, this is a position vector of that particular point which is moving in a space, and r bar is generally denoted as for the position vector, where r bar is given by xi plus yj plus zk. Okay, where I, j, k are the unit vectors along x-axis. Along x-axis, I is a unit vector. Along y-axis, j is a unit vector, and along z-axis, k is a unit vector. Why they are called unit vectors? Because you can write down here also note. Because their magnitude is 1. What is the meaning of magnitude? We are going to see this. Okay, whose magnitude? The vectors. These have particular direction and magnitude as well, and those whose magnitude is 1, and that's why those vectors are called unit vectors. Okay, they are fixed vectors along x, y and z axis respectively, and using these three unit vectors we are going to define the different kind of position vectors of a particle moving in a space. Okay, suppose p is a particle, this is a particle p moving in a space with a position vector r bar. Okay, if you draw these perpendiculars to the x and y axis and z axis, you will get the position of that particular point. Okay, that's why this vector is called position vector of this particular point in a space. Then velocity v of this particular point is denoted by v bar, and it is defined as rate of change of displacement with respect to, in general, velocity we have defined, definition of velocity is rate of change of displacement with respect to time. Displacement means distance traveled by that point, means position of that point in a space, that means position vector. That's why derivative of this position vector with respect to time is nothing but velocity. Okay, velocity vector is also called as a tangent vector. Tangent, what do you mean by tangent? Suppose this is a path of the point. The point P is traveling on this curve in a space. Suppose this P is a point in a random position. Then tangent at that particular point, at that particular position, is nothing but this line which touches this point and this curve in a single point. Okay, this is called the tangent line or tangent vector if it has a direction. Okay, that's why both velocity vector is nothing but the tangent vector also. In most of the example they have asked to find out the velocity vector as well as the tangent vector, both meaning is same. Okay, now acceleration is denoted by a bar, and it is denoted, we know acceleration definition is rate of change of velocity with respect to time, and that's why it is nothing but derivative of velocity with the rate of change of means derivative of velocity with respect to time, and we know velocity is a rate of change of displacement. That's why it is double derivative of position vector with respect to time. Okay, these are the two definitions, main definitions. Now let us see some results of vectors. These are very simple results of derivative also. Derivative of u bar plus, which let u bar and v bar are any two random vectors, then addition of these two and take derivative is nothing but derivative of u bar plus derivative of u bar. Now derivative of phi into u bar. Phi is a scalar. How to differentiate scalar and vector? Vector alphabets contains bar sign, that means they are vectors, and anything like phi, psi, these are scalar functions or only scalar. Okay, if phi is a scalar, then derivative of this is scalar function, means phi is also function of x, y, z, u bar and also function of x, y, z, and t also. Okay, t is a time here throughout the chapter, t is a time. Then derivative is we know u into v rule, u into derivative of v plus v into derivative of u, like that only. The derivative of phi, u bar as it is, plus phi is a scalar function. It is just a rule of u into v rule of derivative. Again this is a u bar into v bar, where u bar and v bar both are vectors. Same rule applied here also. Derivative of u bar, v bar as it is, plus u bar as it is, derivative of u bar. Now this is a cross product, this is a dot product, this is a cross product. In vector multiplication contains two vector multiplication, one is called vector dot product and another is called vector cross product. We are going to see all the definitions here. These are the results. Derivative of u bar cross v bar as it is, plus derivative of u bar into derivative of v bar cross derivative of v bar. These are some results. Now let us see what you mean by dot product and cross product of two vectors. Let us say first dot product of vectors. Suppose r1 bar is a one vector, 2i plus, directly we are going to see the examples. Okay, in terms of examples, 2i plus 3j minus 5k, this is general position vector. R1 bar first position vector. This let r2 bar is minus 3i plus 6j minus k. Okay, now we are going to see the dot product of r1 bar into r2 bar is defined as r1 bar into r2 bar. Directly take the brackets into this v bar, r2 bar. Now what is the how we can calculate the multiplication of these two vectors? It is corresponding multiplication of numbers, I coefficient into I coefficient plus j coefficient into j coefficient plus q coefficient into k coefficient. Like for example 2 into this minus 3, I into I, it becomes I square, and I square value becomes here minus I square, j square, k square values are 1. Okay, that's why it becomes 2 into minus 3 plus 3 into plus 6 plus minus 5 into minus 1. With the sign you have to take this constants. Now addition all these things on the calculator, we get the answer. Dot product of R1 bar and R2 bar is 18. Okay, now let us see what is the cross product. Cross product of two vectors, same vector we are going to consider. R1 bar cross R2 bar means it is a determinant, 3 by 3 determinant, whose first row is fixed I, j, k, and second row will be the coefficient of first vector's I, j, k coefficient. What is the first vector? R1 bar coefficient is 2, 3, minus 5. You have to write down on second line, and third line will be R2 bar's coefficients, IJK coefficient, that is minus 3, 6, minus 1. Okay, now we are going to define this, to simplify this determinant. How to solve the determinant? I into its minor, that is 3 into minus 1, minus 3, minus 6 into minus 5, minus becomes plus 30. Middle sign is minus j, it is minus its minor, that is 2 into minus 1, minus 2 into 5 into 3, already minus becomes plus, that's why it is minus 15, plus k into this minor, 6 to the 12, minus plus 3 3 the 9. Now add this thing, all we get 27i plus 17j, minus becomes plus 21k. It is called cross product of two vectors. Okay, now let us see magnitude of a vector. These are the basic definitions. After that we are going to see the directly examples. Let R bar is any vector 2i plus 4j minus k, then magnitude of R bar is generally denoted by R. Okay, magnitude of R bar is R, magnitude of A bar is A, like that only. And then magnitude of R bar is denoted by R, and it is defined again symbolically write down as magnitude of this R, 2 bars. Okay, and it is defined as under root of the coefficient of I, j, k, its square, 2 square, 4 square, and minus 1 square. This is the definition of magnitude of this vector. Answer on calculator, it becomes root of 21. Okay, this is called magnitude of a vector. Now let us start with the example, simple example first. Let R bar is a position vector, it is given e raised to t cos t I plus sin t e raised to t sin t j be the position vector of a particle. Okay, then what we have to find out? We have to find out velocity and acceleration simply at a time t is equal to 0. Means after finding velocity, by definition we have to put t is equal to 0 in the answer. Okay, let us start with the definition first. Let R bar is equal to, take this e raised to t inside of this bracket, we get e raised to t cos t I plus e raised to t sin t j. Okay, now we know velocity vector v bar is defined as derivative of position vector dr bar by dt. Now take the derivative of this R bar as it is. Now you have to take the derivative of this addition. In the addition, I, j, k, these are the unit vectors, and derivative of unit vectors by taking as a constant. Treat I, j, k as a constant. That's it, because we have to take derivative with respect to t. Except t with respect to except t, everything is constant. Numbers I, j, k, these are the constants. Now we have to take derivative of this plus I into plus derivative of this. Okay, this here derivative is with respect to t, and here two functions derivative is there, that's why u into v rule should be applied. First u as it is, derivative of u into this, suppose cos t is a u into derivative of e raised to t is e raised to t plus e raised to t as it is, derivative of cos is minus sign. Okay, this is first derivative into I as it is. Okay, I, j, k, these are I as it is, plus now here also we have to use u into v rule, e raised to t sin t into e raised to t, derivative is e raised to t, plus e raised to 2 into sin t, derivative is cos t, u into v rule into j as it is. Now we have to simplify for t is equal to 0. Now put t is equal to 0 in the velocity vector, we get everywhere, if you put t is equal to 0, we know cos 0 1, e raised to 0 is 1, 1 into 1 is 1, minus sin 0 is 0, plus e raised to, this is sin 0 is 0, plus e raised to 0 cos 0 is 1 into 1, that is 1 j. Final answer is 1i plus 1j, that is I plus j. This is a velocity vector. Now we have to see the acceleration vector. Acceleration vector a bar can be defined as derivative of velocity vector. We already calculate this velocity vector. We have to take one more derivative of this thing. Therefore, d by dt of this velocity vector as it is. Now, I have to take derivative of this plus derivative of this. Therefore, u into v rule for the both term we should have applied. This is the u into v rule, again u into v rule. Put the all the brackets as it is. We are going to this e raised to t minus e raised to t cos t gets cancelled. A minus e raised to t sin t minus e raised to t sin t gets add minus 2 e raised to t sin t I. This is I. And in this term, e raised to t sin t minus e raised to t sin t gets cancelled. E raised to t cos t becomes 2 times e raised to t cos t j. Okay, this is the acceleration vector. Now we have to put t is equal to 0. It is given in the example. That's why I put t is equal to 0. We get a bar is equal to, here e raised to sin 0 is 0. It is 2 minus 2 as it is, and here 2 into 1, 1 into 1, that is 2 into 1 into j. Final answer is 2j. Okay, item gets cancelled. 2 into 1 into j, that is 2j. This is the acceleration vector. Any vector which contains ijk is called vector, but if any vector contains only I, only j, only k, those vectors are also called as a vector. Okay, not necessary three of them should be exist. Let us see next example. Example number 2. If r bar is a position vector given by e raised to minus t I plus log of t square plus 1 j minus tan k, tan t k, then find velocity and acceleration. This is a homework for you. Okay, like earlier example, find out the velocity. Just take the derivative, double derivative, and put the t is equal to 0. You will get velocity vector as minus I minus k, and a bar is equal to I plus 2j. Okay, derivative of log x is 1 by x, and we have to multiply it again t square derivative 2t. Remember this. Tan s derivative sec square x. Okay, now if you put 0, t is equal to 0 in sec square is not there, but we have 1 upon cos is a sec. Okay, that's why you will take the reverse while finding out the value at t is equal to 0. Okay, use calculator while making the calculations. Now next step is find the angle between two vectors. Suppose two vectors are there, they are intersecting. Suppose they are not parallel, they are intersecting with each other at particular point with the angle theta. Then if we know both the vectors r1 bar and r2 bar, then we can calculate the angle between those two vectors. Okay, let us start with the definition. Let r1 bar and r2 bar are the two vectors, and theta is the angle between these two vectors. Suppose this is r1 bar, this is r2 bar, this is origin, theta is the angle. Then by definition, cos of this theta is nothing but numerator r1 bar into r2 bar divided by mod of this r1 bar into mod of this r2 bar. The simple definition. If angle questions asked, it can be asked for 1 or 2 marks objective. Okay, let us start the examples depend on this definition. Let r bar is equal to, it is given, t cube plus 2i plus 4t minus 5j plus 2t square minus 6tk. This is the position vector given. Find angle between tangent at particular point t is equal to 0 and t is equal to 2. Okay, now we have to find those two vectors first. Then only we can use this definition. What are those two vectors? Those two vectors are tangents. Okay, at two different points, t is equal to 0 and t is equal to 2. Means we have to find out first tangent vector to this position vector, and then we can put t is equal to 0 and t is equal to 2. We get two vectors, and then we can find out the angle between those two vectors. Okay, now first we know tangent. What do you mean by tangent? If r bar is a position vector, we have already seen. Suppose r bar is a position vector, then v bar velocity is nothing but the tangent vector. Therefore we have to find out the velocity vector first. In this example we call it as tangent vector. Now we know tangent vector is nothing but dr by dt. Okay, now derivative of this with respect to t we have to take. In that case I, j, k are constants. Okay, t cube plus 2 derivative, which is 3t square, 2 derivative is 0, I, plus derivative of this bracket is 4 with respect to t is j, plus derivative of this is 2 to the 4t minus 60 derivative is 6 into k. Okay, once we find the tangent vector we have to put t is equal to 0 and t is equal to 2 and call them as by another notation. First put t at t is equal to 0, tangent vector is given by a bar is equal to, put t is equal to 0 everywhere. We get this is 0, this is as it is, it doesn't contain t, that's why I put as it is. 4j plus this is 0 minus 6k, 4j minus 6k, and put t is equal to 2, we get b bar, call it as a bar tangent vector, and at t is equal to 2, tangent vector denoted by b bar, it is called it is turned to be 12i plus 4j minus 2k by putting t is equal to 0 t is equal to in earlier definition. Okay, now we have to find out the angle between these two tangents. Therefore let's define first that theta is the angle between this a bar and b bar. Now we have to write down the formula, that is cos theta is a bar into b bar upon mod of a bar into mod of b bar. Now put the values as it is, a bar is this, b bar is this, into this is the dot product divided by its magnitude. What is the magnitude of this vector? Corresponding I, j, k coefficient square under root of this. 4 square is 16 minus 6 square is 36 under root of this into its magnitude is here. 12 square is 144, 4 square is 16, minus 2 square is plus 4. Okay, now in the numerator 2 vector dot product is there. How to we calculate? Corresponding I, j, k should be multiplied. Here I is not there, that's why it is 0 I. 0 into anything is 0, we no need to write 0. Now j coefficient, 4 into 4 16, plus k coefficient into k coefficient, minus 6 into minus 2 plus 12 divided by this on calculator, this becomes this. Now to calculate on calculator we get this answer, cos of theta is equal to 7 upon root 13 root 41. This is called angle between two tangents or two vectors. Okay, now let us start with another definition. Operator del, this triangle lower triangular symbol is called del. It is a derivative operator and it is defined as del is equal to deb of deb x. We know this is a partial derivative. Deb of deb x I plus deb of deb y j plus deb of deb z k, or dou by dou x. Okay, these are the partial derivative. What do you mean by partial derivative? With respect to x, these are the simply derivatives. All derivative rules are same for partial derivative also. But when it is partial derivative with respect to x, y and z, we keep it as constant. With respect to y, x and z are constant. With respect to z, whenever we are taking the derivative with respect to z, x and y are constant. Simply, this is the only rule between partial derivative, difference between partial and total derivative. Let's start with the example. Here are some, these are already we have discussed scalar definition and vector definition. Now we are going to see one more definition, gradient of a scalar function, that is del phi. Del we already know, just join or multiply phi with that del, and we know del phi is nothing but deb of phi by deb xi plus deb of phi by this phi by deb yj plus deb of phi by deb z k. This is a definition of gradient. This is called gradient. Okay, now what is the geometrical meaning of gradient is here. Write down as a note. If phi is a scalar surface, phi is a scalar function means it is a surface, it is not a plane. Okay, if phi is a scalar surface in a space obviously, then del phi, that is gradient of phi, is nothing but normal to the surface. Normal means perpendicular. Okay, normal line means the line which cuts the other line to the 90 degree, that means 90 degree angles line or perpendicular line to the surface. Okay, suppose for example Suppose this is a surface. Suppose this is a surface. This is a plane. Okay, this paper is a plane. If you bend this, it becomes surface. Okay. Now suppose a particle is moving. Okay. Suppose this is a surface. Okay. Okay, then suppose particle is moving on the surface at particular point, then okay, suppose this is a this is a plane, and if you bend this, it becomes surface. Okay, suppose this is a particle, P is a moving on the surface. This is what we get, the curve. On plane it is a straight line. If you bend this, it becomes curve. Okay, and suppose particle is moving on this curve at this particular point. If you draw the perpendicular line like this, okay, this line is called the del phi. If it is phi, the surface is a phi at a particular point. If you take the perpendicular, this line is called del of this phi. This is simply the geometrical meaning of a del phi. Okay. In mathematical meaning, perpendicular is called normal surface, normal line to the surface. Okay. Let us start with the example. If r bar is a position vector with mod of r bar is r, these are the simple notation. Then evaluate r bar is a position vector. We have to mug up r bar is nothing but xi plus yj plus zk in general. Okay, it is position vector of any particle. Then we have to find out these four: del of r, del of 1 by r, del of 1 by r square, del of r raised to m. Okay, first we have to define r. R means modulus of r bar. Let r bar is equal to xi plus yj plus zk be the position vector of a particle moving in a space. Then r bar, mod of r bar is nothing but r. It is defined, it is well known, and it is defined by an under root of modulus defined as under root of x square plus y square plus z square. This is a standard definition of model. Now to find out, these are the derivative terms. Now we have to find out these things. Take the square on both sides, because taking the derivative of root and taking the derivative of square, in both the cases taking the derivative of square is very much easy than root. That's why to cancel out this root, take the square on both sides, we get r square is equal to x square plus y square plus z square. Now we have to differentiate. Here there are three variables x, y and z. R is a variable which is a function of x, y, z. Now differentiate above equation with respect to x. What we get? Derivative of r square is 2r into r derivative should be multiply with respect to x, that is dou r by dou x. This is a partial chain rule derivative. Derivative chain rule is equal to derivative of with respect to x. This is a partial derivative, therefore y and z are constant. Derivative of x square is 2x. Derivative of yz is constant, derivative is 0. 2 gets cancelled, dou r by dou x becomes x upon this r. Okay, now in this r square, x, y, z terms are similar. X square, y square, z square. Those terms comes in a similar fashion. That's why we can similarly write down dou r by dou y. If dou r by dou x is x by r, then we know dou r by dou y becomes y by r. Dou r by dou z is z by r. These are the cross only. This x is here, r is here. Okay, these are the standard derivatives we are going to use in every example. Let us start with first. Del r. Del r is dou r by, we know definition of del r is dou r by dou xi plus dou r by dou yj plus dou r by dou z. Okay, it is a definition of del phi. Instead of phi, here instead of phi there is r, therefore we have to replace phi by r everywhere. Now dou r by dou x is x by r, dou r by dou y is y by r, dou r by dou z is z by r. just we have earlier calculated as it is. Write down those things. Now take this denominator common, 1 by r. The bracket remains xi plus yj plus zk terms, and we know this is the original position vector r bar divided by this r. Okay, first question complete. Now second question, where to find out del of 1 by r. Del of 1 by r. Now start with the definition. Del of 1 by r is dab of dab x of 1 by r I plus dab of dab y of 1 by r j. Replace by r everywhere, 1 by r this term. Or in del phi, replace phi by 1 by r. Dab of dab z of 1 by r k. Now we have to calculate first this dab of dab x of 1 by r. First 1 by r derivative should be written down, minus 1 by x derivative is minus 1 by x square. That's why its derivative is minus 1 by r square into r derivative should be multiplied by chain rule of partial derivative. That is dab r by dab x here. Now we know dab r by dab x is x by r. We already calculated in earlier bit. And now r square into r becomes r cube minus x upon r cube. Okay, now this is the first calculation of this term. Derivative of 1 by r with respect to x is minus x by r cube. Similarly, we can write down derivative of this 1 by r with respect to y is minus y, replace x by y, minus y by r cube, and derivative of 1 by r with respect to z is minus z upon r cube. Okay, write down these three terms here. We get first equation becomes del of 1 by r becomes minus x upon r cube I minus y upon r cube j minus z upon r cube k. Take the 1 by r cube and minus common, minus 1 upon r cube common. In bracket it remains xi plus yj plus zk. And again we know xi plus yj plus zk is r bar divided by this rest of the terms are as it is. Okay. Now third, similarly we have to find out third term del of 1 by r square. This is the third bit. Okay, let's start with the definition. Del of 1 by r square is dab of dab x of 1 by r square I, dab of dab y of 1 by r square j, plus dab of dab z of 1 by r square k. Call that equation number 1. First we have to solve this derivative. Dab of dab x of 1 by r square is nothing but first 1 by r square derivative should be that is it can be written as r raised to minus 2, and r raised to minus 2 derivative should be written first, that is x raised to n derivative should be applied here, minus 2 into r raised to minus 2 minus 1, that is minus 3. Again r derivative should be multiplied with respect to x, that is dab r by dab x. Again dab r by dab x is nothing but x upon r, as we have solved it earlier, and r into r cube is r raised to 4. Therefore answer for dab x of 1 by r square is minus 2x upon r raised to 4. Now similarly we can write down dab of y of 1 by r square is minus, just replace x by y, minus 2y by r raised to 4, and dab of z of 1 by r square is minus 2z upon r raised to 4. Okay, now put all these values in this first equation. We get del of 1 by r square is nothing but minus 2x upon r raised to 4 I minus 2y upon r raised to 4 j minus 2z upon r raised to 4 k. Now take minus 2 upon r raised to 4 common. In the bracket it remains xi plus yz plus zk, and value of this is r bar. Therefore answer is minus 2 r bar upon r raised to 4. Okay. Now fourth last term is we have to find out del of r raised to m. Now again find write down the definition, del phi definition, where phi is replaced by r raised to m everywhere. Dab of dab x of x raised to m I, dab of y of x raised to r raised to m j, plus dab of z of r raised to m k. Call that equation number 1. First we have to find out this derivative. Dab of x of r raised to m. R raised to m is derivative is m into r raised to m minus 1. And into r derivative should be multiplied by using partial derivative chain rule, dab r by dab x. And we know dab r by dab x is nothing but x upon r. Now take this r to the numerator, m into x into r raised to m minus 2. Okay. Similarly, dab y of r raised to m becomes just replace x by y. and above double z of x where r raised to m is just replace x by z. Okay, now put this 3 value in this above equation. We get from equation number 1 del of r raised to m is nothing but this plus this I, this first term I plus second term j plus third term k. Now take the common m into r raised to m minus 2. In the bracket it remains xi plus yj plus zk. And the value of this is r bar. This term as it is. Okay.